Right, so as you all can see, sections 2 and 3 are actually going to go together. They're on the same page. So we're going to go through both of those in this video, although section 2 is really short. Typically, I would actually have you guys watch a Galapagos video, but since you're not in the classroom with me, I can't really do that unless you have access to that series on Amazon Prime, which is where I found it to begin with. Right? You can look up all you want, Netflix, whatever resource. See if you can find something about Darwin or the Galapagos. Maybe you'd be able to see some of those things. But since that's not really an option, I'm just going to go through the vocab you might need for this section, and I'd like you to obviously use your book to answer questions, right, in your study guides. So we're going to talk about how Darwin observing that variation led him to believe that species can adapt in their environments. Okay, so just some definitions to start out. Right? We got variation, difference in physical traits among individuals of the same species. Now, technically, this is called intraspecific variation. There is an interspecific variation in your book as well that you'll use on a study guide. But since I'm saying same species here, it's definitely the intra version. That's the one we use most of the time. The other differences, right, are more obvious and don't matter as much. Adaptations, though, are features that allow an organism to better, I'm gonna grab it, survive in its environment. So, adaptations, we talked about those a long time ago. You should be able to give me an example of an adaptation. I may ask for that again on a quiz or a test. So whether you talk about your thumb or a cat's tail, how it helps it balance, right? Any adaptation that helps an organism better survive, right? Any feature that allows an organism to better survive in its environment is considered an adaptation. Some things to remember: adaptations are things that individuals are born with. They don't choose to have them, right? I was born with a thumb. I didn't decide, oh, that'd be useful one day and just paste it onto my hand, right? Otherwise, individuals cannot adapt themselves, right? It's a population phenomenon. Some individuals will have that trait, some individuals won't. But as far as the population is concerned, that's good that there's differences because it can evolve, right? A species can evolve because the different traits can be selected for. Again, down at the bottom, Darwin has also observed fossil and geological evidence that supported the idea of an ancient Earth. Those are the things you're going to have to look at your book for. Right? So again, kind of a weird section. Make sure you use your book as a resource or the packet, depending on who I'm talking to here. But otherwise, section 3 stuff, we can definitely go through together in the notes and get that all figured out. So your objectives in section 3 are to talk about artificial and natural selection. Understand how they're similar, how they're different, why the artificial selection mattered to Darwin at the time. And then we're going to examine the factors that Darwin considered in forming his theory of natural selection. There are 4 principles for that natural selection, and we're going to go through those things and talk about how it works. Right? So Darwin is considered the father of evolution, not because it was his idea, but because he came up with the mechanism that could explain how it works. So natural selection is really important for that. Okay, so first, just a few definitions. Artificial selection: you're going to change a species by selecting and breeding to obtain certain traits. Again, one of the major examples where that jumps out at you with would probably be with dogs. We have lots of different breeds of dogs at this point, and they all exist for certain traits that they have. Right? Some are hunters, some are herders, right? Some are just cute and cuddly. But dogs and those breeds of dogs that we have created ourselves, right? That's an example of artificial selection. Now, we've done that with a million different things, right? Many animals have been domesticated, right? So we're selecting for traits there. Many plants have been artificially selected, right? Corn looks nothing like what it did when we first got a hold of it. So understand that artificial selection, a lot of different examples, but why would that matter? Right? Apparently, we can change a species by selecting for certain traits. You can see that happening, even in a short period of time, relatively. So that was something that Darwin looked at and decided, okay, if we can make that species change, maybe nature can do the same thing. Right? Again, one key is heritability. Right? If that trait wasn't passed on to the next generation, then there's really no point in finding those two dogs that were really, really good hunters and breeding them together. Right? If that wasn't an innate ability that could be passed on, right? If it wasn't just naturally going to be good at this thing, you just had to train it all over again, then there would be no point in those species, in those breeds, existing to begin with. But some breeds are actually just innately able to do certain things and be really good at them. Right? So heritability is key. It has to be a trait that's passed on from one generation to the next. That advantageous trait, that adaptation in natural selection, needs to be passed on. It can't just be something that the parent has, the offspring have to have it too. Right? Natural selection is a mechanism by which individuals have inherited beneficial adaptations that allow them to reproduce more successfully. So there's one more blank over here. So again, it says reproduce more successfully. Again, it's not just that you survive, your offspring also have to survive for this to be good. But natural selection, kind of like artificial selection, it's just nature that's actually doing the work, right? You're still selecting for certain traits. They just happen to be traits that benefit that organism, not necessarily something that benefits us, the humans. So when we compare and contrast those two things, right, again, normally I'd have you help me do this, but we'll do what we gotta do. I can put things that they both have in common in the middle. Say this side is artificial selection, this side is natural selection. Right? Remember, keys to both, right? Those traits need to be heritable. Because obviously, if you look at the names, they both select for certain traits, right? But those traits also need to be heritable. They need to be passed on to the next generation, or they would have no effect on that species. They wouldn't change that species. And that's the second part that both have in common. Both change organisms over time. Now, that can be different for both, right? We can actually create a breed of dog in thousands of years. Natural selection would create new species over millions of years. Right? One takes much, much longer than the other one. So the time is different, but they both change organisms over that time. Artificial selection, again, humans, select those traits here. That's why it's actually faster, because we can make sure that the breeding occurs that needs to occur to pass that trait on. Right? Whereas on the other column in natural selection, it's actually the environment that selects. Other differences, just to point out, because it's a good thing to understand, here the trait is supposed to benefit the humans themselves. Remember, some of those things that we've selected for over time, and actually this breeding thing that we've done with dogs is actually sometimes harmful to that organism. Because what we're doing is selecting something that helps us, but it doesn't necessarily help that organism, right? Or because of the fact that there's not very much variation in that breed over time, it can actually hurt them at some point, right? So when you have a lab that has hip issues, and that's a very common thing for labs at this point because of the breeding over time. So again, these traits in artificial selection specifically benefited us, whereas on the other side, natural selection, that trait would always benefit the organism itself. What other organism we were talking about. So again, there are some major differences, but because they are similar, because they both can change an organism over time, right? That's why artificial selection was so important for Darwin. Right? He knew we could do it. He knew we could change organisms, but could nature do it? Right? Could the environment do that? So that's where we come into these four main principles of natural selection. Right? He determined that these four things have to be happening in order for a species to evolve, in order for it to change. Right? Number one, there has to be variation. That should be obvious. Right? You have to have different traits in a population before you can start choosing from those traits. So different traits to choose from, that's key. If all individuals were identical, they'd all be equally capable of surviving and also equally vulnerable to extinction. So you have to have different traits in that population in order to choose specific traits. Overproduction, second key. There has to be more offspring than can possibly survive. It all comes down to resources, right? These adaptations we're going to talk about help organisms obtain those resources more effectively, right? So if there's plenty of resources, if there's plenty enough to go around, there's really no reason for those species, for those organisms to worry about whether they have an adaptation or not. There has to be some kind of competition. There has to be competition of some kind. They have to have limited resources before any kind of pressure could be coming from that environment. Right? Pressure that's going to choose some adaptation, right? Some trait. That gives an advantage. So adaptations give individuals an advantage, help them obtain those scarce resources that we're talking about. And because of that, they're better able to survive. Because of that, those organisms are the ones that are going to have offspring that are going to pass on traits to the next generation. So descent with modification just means that if only certain organisms are surviving, then the traits that those organisms have are being passed on to that next generation. So those adaptations we just talked about are passed on to that next generation. So again, from top to bottom, you have to have different traits to choose from to begin with. Right? If all organisms are identical, they're all equally capable of surviving. Overproduction, if some individuals cannot obtain those resources they need to survive, then only the ones with advantages do. That's where the adaptation comes into play, right? And then those organisms that survive pass on their traits to the next generation. That's why that adaptation becomes more and more frequently occurring in that new generation. So if only birds with strong beaks that could break through the hard shells of the nuts that were available that year, that season, were surviving, then that next generation, that next year, there'd be more and more birds with big, strong beaks to take advantage of that food source. It's pretty simple, actually. But these four things are key. They have to be there every time. Finally, natural selection is sometimes summarized as survival of the fittest. Now, I like and dislike that. It does actually make sense if you understand what fitness means in biology. But otherwise, when we think fittest, sometimes we just think bigger, faster, stronger, and that's going to be a problem, right? So you have to think when you're looking at fitness in biology. It's not the same thing you always think, right? All that it means is it's a measure specifically of the ability of an individual to survive and produce offspring that survive. So again, it doesn't actually really matter what it is. It just matters that it helps that organism survive. Right? Survival, as you can see below, is dependent on the ability to obtain those limited resources. So again, those adaptations are key. They help you get those resources. Right? Some individuals have those adaptations, and those are the things that are passed on. But again, you're going to look at this word. You're going to say survival of the fittest, and you're always going to think bigger, faster, stronger, and it's kind of hard to get that out of your brain, right? Because humans are not bigger, faster, or stronger than any of our relative primates, right? So you add in new possibilities, right? That's not our adaptation. Our adaptation is that we're smarter, right? We can use tools, right? So don't always think bigger, faster, and stronger, because sloths have survived for millions of years, right? And they're not fast, right? They're called sloths for a reason. But they don't have any major predators, so it doesn't matter if they're fast, right? All that matters is that they conserve energy so that they don't have to eat as much, right? It's pretty simple, right? Or you could be a tortoise that carries around a shell on your back to actually protect you instead of needing to be big and fast to protect yourself. So there are a lot of different solutions that nature has come up with, and it's not always bigger, faster, stronger. So when you see fitness in biology, it does not mean bigger, faster, stronger. It can mean bigger, faster, stronger, because in some species it's beneficial to be bigger, faster, stronger. It just doesn't always mean that, because we're actually smarter. Right, so that should be all we need.